I'm Cesar, and today we'll be doing another problem involving electrostatics. We have this simple system of 3-point charges. One is Q1, whose charge is 1.4 to 10 times 10 to the minus 8 coulombs. Q2, which is minus 1.8 times 10 to the minus 8 coulombs. And Q3, which is 2.1 times 10 to the minus 8 coulombs. We want to know what is the total acting force upon Q3. For this, we will do the sum of both forces, the one between Q3 and Q1, and the one between Q2 and Q3. First, we have to take into account the values of each of these charges. As we know, Q2 is a negative force. Has a negative charge, while Q3 has a positive one. Thus, the force acting between Q3 and Q2 will have this direction, since Q3 will feel attracted to Q2. On the other hand, Q1 being both positive as Q3 implies that the force between Q3 and Q1 the force felt by Q3 due to Q1 will be a repelling one. Thus, the sum of these two forces will be a vertical added to a descending diagonal line, which leads us to believe that the force will be something kind of similar to a vertical, but we cannot just assume whether it'll be an ascending or a descending one. To begin this problem, we'll take the most simple approach, which is starting with the Q3-Q1 force. Thus, F Q3-Q1 will equal K times Q3 times Q1 divided by the distance, which is 0.24, and multiplied by the unit vector of that force, which in this case will be 0, 1. We input all of these values and get that the result is K, which is 9 times 10 to the 9th times 2.1 times to the minus 8 times 1.4 exponent minus 8 divided by 0.24 squared. Well, I forgot to mention that it's 0.24 squared, excuse me. And we get that the resulting force will be the vector 0 for the x component and 4.6 times 10 to the minus 5 for the y component. And this is one of our forces. The second force will be the one between FQ3 and Q2. Again, it's K times Q3 times Q2 divided by the distance, which will be the square root of 0.24 squared plus 0.18 squared. So we'll just remove this square root, and right underneath here, 0.24 squared plus 0.18 squared, and this will be the net force, which will in turn be divided by 1 over the square root of all of this mass, 0.24 squared plus 0.18 squared, 18 squared, kinda, which is the magnitude of this vector, which is 0.18 and 0.24. So we'll input all of these values. 9E9 times 2.1 E minus 8 times 1.4 E minus 8, 1.8, excuse me, 8 E minus 8 divided by 0.24 squared plus 0.18 squared, and this will be elevated to 3/2, in other words times to the 1.5. Right, yep, yeah. And this gives us a resulting force of 1.26 times 10 to the minus 4 with a unique vector, which will be, that's 18. Oh, I forgot. This should be a negative sign because we know it's a downward force. And minus 0.24. As we can see, the only vertical component, the only horizontal component is this one. So the resulting force will be the vector, this component of the force. So it will be our result times dot 18, which is 22.27 times 10 to the minus 5. And for the y component, we'll have the sum of both. So we have 1.26 e minus 4 times dot 24. This will be 3.024 to e times 10 to the minus 5, and this will be a negative number, so minus times minus 1, and this will be summed to 4.6 times 10 to the 5th to the minus 5th, excuse me, and that leaves us with a total result of 1.58 times 10 to the minus 5. This is our resulting vector. As we can see, we did end up with a positive result, so the resulting vector would be something like this. And this is in itself the vector. We can, however, calculate the angle of this vector, so we'll just input these values into the inverse tangent of the y component, 1.58, divided by the x component, 2.27. We'll omit the exponents because they're exactly the same, so we're just dividing everything by 10 to the minus 5, and we get that the result theta, wait a minute, there, theta will equal 34.84 degrees. So this angle up here will be 34 degrees, and we can also calculate the magnitude. So we'll have 2.27 e minus 5 squared plus 1.58 e minus 5 squared, and the square root of all of this gives us that the magnitude will be 2.77 times 10 to the minus 5 newtons. And these are final results. I'm really sorry for this. For the quality of this video, I didn't have someone to record me. I hope this has proven useful to someone somewhere. And thus I say goodbye. Thank you.